Hello everyone, this is A.THASNI from SNS College of Engineering from Department of Computer Science and Design. Now we are going to see about the binary classification and predictive performance measures. So the binary classification and predictive performance measure. What's binary classification? So definition of binary classification is classification problem with the two possible outcomes. Example spam, whether it is a spam or not spam, or it is a true or false. Either any one solution should be the possible outcome. For example, we are going to see about the fraud detection. Fraud detection, either is it a fraud or not a fraud mail, or spam mail or not a spam mail. And in the medical diagnosis, whether they have the disease or no disease, or whether it is they are having high or low. The main importance of this binary classification is common in the real world machine learning task. Some of the common binary classification algorithm is logistic regression, decision trees, support vector machines, random forest, neural network. That we for the support vector machines we can call it as SVM, and the neural network is just a basic overview of the binary classification algorithm. Now the confusion matrix. What is confusion matrix? There are in confusion matrix there are only four elements. What are they? One is true positive and true negative, and false positive and false negative. These are the main four elements that we are going to use in the confusion matrix. The visual example of a confusion matrix table is something which related to the true negative or true positive one based on the true negative, false positive and false negative. And next is the accuracy as a performance matrix. The accuracy is the proportion of all classification that were correct, whether positive or negative. Either any two solutions should be there. It is mathematically defined as accuracy equal to correct classification or total class divided by total classification. Okay, total classification which refer to all the true positive, true negative, or false positive, false negative. That is the total classification. And the correct classification that we diagnose that whether they have the disease or not a disease in fraud detection, whether they have the whether they got the spam mail or not a spam mail. So either it should be a true positive or true negative. This is my correct classification. Either it can be in a mixed way, false positive and true negative, or true negative, true positive or false negative. Anything it can be. That is depends on our identification. So here the formula is true positive and true negative divided by the true positive plus true negative plus false positive plus false negative. When accuracy is useful and its limitations, especially with imbalanced data, where we have the imbalanced data or not a balanced data, imbalanced data which is not in a correct format, that we are going to see about the performance. Next one is the precision and recall. Precision is nothing but true positive or true divided by true positive plus false positive, focusing on minimizing false positive. That is becoming in from the precision method. Focusing on a minimalized false positive, that is called it as a precision. And recall, it should be a sensitivity, that is true positive divided by true positive plus false negative. Sensitivity, how sensitive it is, and either in a balancing precision, recall can depending on the problem context. So the F1 score is combining precision and recall. F1 score is combining precision and recall. The formula will be 2 into precision into recall divided by precision plus recall. The main use case that we are going to use here is when precision and recall are both important. Example to show how F1 score is calculated. To calculate that F1 score, combining both the precision and recall, we are using this formula such as 2 into precision into recall divided by precision plus recall. Next one is the ROC curve. ROC curve and AUC, that is area under the curve. ROC curve is nothing but plot of true positive rate recall versus false positive rate. AUC is nothing but area under the curve, measure of the classifier's ability to distinguish between classes. Higher AUC means a better model. Other important metrics are specificity, that is true negative divided by true negative plus false positive, useful when negatives are more important. Matthews correlation coefficient, that is we call it as MCC, it's a balanced measure for binary classification. And we have something called as a log loss, that is measure the probability estimates for the classifier. The main conclusion here we are going to see about the summary of key metrics: accuracy, precision, recall, FN score, and AUC. Importance of choosing the right metric based on the problem. Mentioning the trade-off between the different performance and measures. And we have seen the encouraged understanding of data context between the evaluating model.